We're going to talk a little bit about oxidation reduction or redox reactions. These reactions involve a transfer of electrons between the species in the reaction, resulting in changes in the oxidation numbers of elements in those species. And so what we have here is a bottle containing a aqueous solution of silver 1 nitrate, and over here we have a penny which is clad with copper. And what I'm going to do is I'm going to take this solution and pour it in onto the penny. And we're going to let that sit for a little bit while we talk about redox reactions in more detail. So again, we have a transfer of electrons between reactants and we get changes in oxidation numbers. Every redox reaction involves an oxidation and a reduction half reaction. So you can see already that this copper penny has already turned to a silvery color. All right, and what's happening is there are electrons changing hands, so to speak, between the species in the reaction. So we're going to talk about this a little bit more here. One of these species is losing electrons, and one of these species is gaining electrons. And what we have here there are a couple mnemonics we can use to work this out. There's the mnemonic Leo says GR. Leo is loss of electrons is oxidation. That will be an increase in oxidation number. And GR is gain of electrons is reduction. This is always confusing to me when I first learned this, because how can something be gaining something be called reduction? Okay, when you gain a negatively charged electron, you have a decrease in the oxidation number, so that's where the word reduction comes in. Another mnemonic that has been popular over the years is what's called oil rig, okay, which is oxidation is loss of electrons and reduction is gain of electrons. Some other terms we want to bring into play here is oxidizing agent. These are things that oxidize other species. They themselves are reduced. And reducing agents, which reduce other species, and they themselves are oxidized. So now you can see over in the corner here that this solution has actually turned pretty dark here as this redox reaction takes place. Okay, so what we have going on here is we have silver 1 nitrate reacting with copper in the penny. So the silver nitrate solution is aqueous and the copper is solid. Okay, and if I want to turn this into an ionic equation, so this would be a molecular equation. If I wanted to make this an ionic equation, complete ionic equation, I would write silver 1 aqueous plus nitrate aqueous plus solid copper. And what's actually happening here is the copper is getting oxidized to produce copper 2 ions, okay, and the silver is getting reduced to produce solid silver metal. And the nitrate ions really are just spectator ions. Okay? But if you look at this, you can see that this is not a balanced reaction. Okay? Good redox reactions are balanced with respect to atoms, which this is balanced with respect to number of atoms, but it's not balanced with respect to charge. Okay? It's also balanced with respect to electrons transferred. So to balance this out, what we need to do is we need to put a 2 in front of the silvers and the nitrates. like that. And so in the molecular equation, this is 2 silver nitrates plus copper goes to produce 2 solid silver atoms and produce copper 2 nitrate in aqueous solution. So these are balanced. Now, if I want to write the net ionic equation here, I could highlight my spectator ions like that, and I could write the net ionic equation, which would be 2 silver ions plus solid copper goes to produce copper 2 and 2 solid silver metal. And so this is a balanced net ionic reaction. Now, let's think about this. Let's take a closer look. We have the copper increasing from copper 0, if you want to call it copper 0, to copper 2. And so this species is being oxidized. When you talk about what's being oxidized and what's being reduced, you're really talking in the context of the reactants. So this is being oxidized, and this causes the reduction of the silver. The silver is decreasing in oxidation number from silver plus to silver 0, and so this is being reduced. If the copper is being oxidized and it's causing the silver to be reduced, the copper metal is being the reducing agent. It causes the reduction of the silver ion to silver metal. By the same token, the silver ion is causing the copper 0 to get oxidized to copper 2. And so the silver ion is the oxidizing agent. It causes the copper 0 to be oxidized. Now, it's really not very clear to see in this particular reaction, but sometimes if you you can see all the little gray silver crystals, but sometimes you can actually see the solution turn sort of bluish, which is indicating the presence of the copper 2 ions. I don't necessarily see that's going to happen today. Now, what we can also do is we can also break this complete reaction, okay, into 2 half reactions. And in the half reactions, you can actually show the electrons transferring, okay? For example, we can talk about a reduction half reaction. And for the reduction half reaction, it's the species involved in the reduction itself. And so I could take, say, 2 silver cations. They would gain 2 electrons to produce 2 silver metal atoms. Now I can divide through everything by 2, and so I could simply write silver cations plus 1 electron go to produce a solid silver metal atom. Okay, I can also write an oxidation half reaction where I go from solid copper 0 to copper 2 plus. In order for that to happen, I have to lose 2 electrons, which I show then 2 electrons on the product side. But you can perhaps see that if I take this half reaction and this half reaction and add them together, that is, add together everything on the reactant side and everything on the product side, and I cancel out identical species on each side, which would be the 2 electrons on each side, I would go back to this reaction. So let me show you this. Okay, if I add these reactions together, I would have 2 silver ions plus solid copper plus 2 electrons goes to produce copper 2 ions plus 2 solid silvers plus 2 electrons. And you can see if I cancel out the identical species on each side, the 2 electrons, I'm back to where I started. So again, we can see that we've produced some gray solid silver crystals, some silvery colored silver crystals too. The solution's not really turning as blue as I would hoped, but we're definitely seeing the solid silver. I also want to show you this. This is a piece of polymer, silicone polymer, with some very, very, very tiny silver crystals in them, on the order of maybe 100 nanometers across, perhaps. And when silver metal gets that tiny into what we call the nanoscale size regime, they're no longer black or gray or silver colored. They actually appear to be this yellow or almost golden color.